How can patterns help you divide large multiples of 10? Think about this question during the lesson. A jet carries 18,000 passengers in 90 trips. The plane is full for each trip. How many passengers does the plane hold? What operation can be used to find how many passengers were on each trip? You can divide to find how many people were on each trip. How does knowing that the plane is full for each trip help you solve the problem? It lets you know that the same number of passengers rode in the plane on each trip. Think of a basic fact to help you find 18,000 divided by 90. How does simplifying the problem to 18 divided by 9 help? 18 divided by 9 is a basic division fact and is easier to start working with than 18,000 divided by 90. Think about multiples of 10. 180 divided by 90 is equal to 18 tens divided by 9 tens, which equals 2. 1,800 divided by 90 is equal to 180 tens divided by 9 tens, which equals 20. The pattern shows us that 18,000 divided by 90 equals 200. So, the jet can hold 200 people during each trip. 18,000 divided by 90 is equal to 1,800 tens divided by 9 tens, which equals 200. How would you check to make sure your answer is correct? You can use multiplication to check your answer. Understanding patterns of multiples of 10 can help you divide.
Hello, hello. It is your friendly neighborhood math teacher, and today we're going to cover Unit 4, Lesson 1, which is using patterns to divide. This lesson is actually really easy because it's going to focus on kind of the basics of what we need for this unit, which is dividing numbers that are multiples of 10, dividing numbers that have zeros in them. And just like we learned with multiplication, when you are using zeros with numbers, we can kind of manipulate those zeros to make our problem a little bit easier. And the same can be said when we're dividing. It doesn't just work with multiplication. So I'm going to look at a problem. I have 240, let me make that a little bit bigger, 240 divided by 10. Now, here's the rule for dividing. It's slightly different than the rule for multiplying. When we're dividing is repeated subtraction. You're subtracting the same number over and over again. You're breaking it into smaller pieces. So when we are dividing with zeros, emphasis on dividing, because this is different than multiplying, we can get rid of zeros permanently if we have the same number of zeros on both sides. So for instance, 10 has 1 0. 240 has 1 0. Since they have the same number of zeros on both sides, we can cross them out permanently. I'll put an X through them. And then we're left with a simpler problem. The simpler problem that I have is now 24 divided by 1, which is really easy because anything broken into one group, it stays the same. Anything divided by 1 stays the same. So 240 divided by 10 equals 24. Now, if we have a problem, and I'll use the same number, if we have a problem where our zeros are uneven, where I don't have the same number of zeros on each side, this is where we get a little different than multiplication, and this is where we need to pay attention. What we're going to do when we're dividing problems with zeros in it is we're going to first cross off the same number of zeros on each side. So I'm going to look at 2,400, there's 2 zeros, and I'm going to look at 10 and there's 1 0. I can cross out permanently, we're not going to give it back, I can cross off permanently whatever number of zeros they have in common. So in this case they have 1 0 each in common. Now I'm left with a simpler problem. I have 240 divided by 1. Now what I can do is I can borrow my remaining zeros. So we're going to erase permanently the same number of zeros on both sides. And now that I have an uneven number of zeros, there's no more zeros that I can get rid of forever. I can borrow what I'm left with to make my problem easier. But this one I have to give back. So 24 divided by 1 equals 24. And I give back that 1 0. And I get 2,400 divided by 10 equals 240. So the way it works with zeros is we're going to cross off permanently the same number of zeros on each side that they have in common. So if they both have 1 0, if they both have 2 zeros, so whatever they have equal on both sides, we'll get rid of them forever. And then whatever's left over, we'll borrow until the end and then give it back. Let's practice that. It sounds more confusing than it really is. So for instance, if I have 2,800 divided by 70, first thing I want to do is take a look at my numbers and see how many zeros they both have in common so that I can get rid of them permanently. 70 has 1 0, so I can erase that forever. And 2,800 has 2 zeros, so I can erase 1 0. I had 1 0 over here, 1 0 over here. I can't erase all of my zeros, just the same number of zeros on each side. That's simplifying my problem. I'll show you that again. So what I did is I had 1 0 here, and I had 1 0 here. I'm going to erase those zeros that they have in common permanently. That simplifies my problem. Now I'm left with 280 divided by 7. Now that I have no more zeros in common, no more zeros on both sides, I can borrow, and I use one little line, borrow this remaining 0 to make my problem easier. 28 divided by 7 is 4. Give back the 0 I borrowed. So my answer is 40. 2,800 divided by 70 equals 40. Now, this isn't very much different than when we were multiplying. The big thing to remember is that in this case, you're getting rid of zeros permanently if we have the same number of zeros on both sides. When we're multiplying, we always borrow them and give them back. But when we're dividing, we can get rid of some permanently if we have the same number of zeros on both sides, and then we can borrow what we're left with. Let's try another problem. If I have 6,300 divided by 90. First thing I want to do is I want to see how many zeros they have in common, how many zeros are the same on each side. 90 has 1 0. 6,300 has 2. I can get rid of 1 0 on each side. I can erase it, I can put an X through it, whatever's easiest. Now I'm left with 630 divided by 9. Now that there's no more zeros next to the 9, now that the 9 is all by itself, there's no more zeros in my divisor, now I can borrow the zeros that are left over. I'm going to take 630, borrow that 0, and do 60 divided by 9, which is 7. Now I'm going to put that 0 back, and I get 6,300 divided by 90 equals 70. Pretty easy. Let's try another one. Let's do 2,000 divided by 20. Same thing. I have 1 0 on this side, so I want to get rid of 1 0 here, and I want to get rid of the same amount of zeros here, so 1 0 over here. Now I have 200 divided by 2. I can borrow these 2 zeros. 2 divided by 2 equals 1, and put those 2 zeros back. So my original problem, 2,000 divided by 20 equals 100. All right, let's try another one. Let's do 21,000 divided by 700. Now this one's a little bit different. My divisor, the number that's doing the dividing, is 700. 700 has 2 zeros. So what I can do is I can get rid of 2 zeros over here, and I can get rid of 2 zeros over here. Now I'm left with 210 divided by 7. Borrow that 0. I have 21 divided by 7, which is 3. Give back my 0 that I borrowed, and my answer is 30. Now you have to pay attention that there's the same number of zeros on each side. I couldn't do 200, well, it wouldn't work out that way. I couldn't do, if there was 2 zeros over here, but only 1 0 over here, well, that one number would be bigger, so it wouldn't work. But for instance, if I did 210 divided by 100, this would end up giving us a decimal, but you can't get rid of 2 zeros over here and just 1 0 over here. You have to get rid of the same number of zeros on both sides. If you don't get rid of the same number of zeros on both sides, it throws off your answer, and your final answer will not have as many places in it as you need. So you need to make sure that whatever you take away from the right side, you take the same number of zeros away from the left side. We always start with the divisor because that's the smaller number. So we always want to start by taking away the zeros on the right side, which is our divisor. So I'm going to cross off 2 zeros here and 2 zeros here, and now I have 720 divided by 2. I'm going to borrow this 0 because there's not another 0 over here to get rid of. I have 72 divided by 2, which equals 36. Put my 0 back, and I get 360. So this lesson is actually really, really easy. Go ahead and try your follow-up problems on your own and see how you do, but as long as you remember that you can take away permanently the same number of zeros on each side and then borrow any zeros that are left over, this lesson becomes super simple. Good luck, guys, and let me know if you have any questions.